Okay, so this is the last lecture for 2020 spring. Math 112 rational functions, a full graph. To graph rational functions, we want to do these three things. We've talked about end behavior. We talked about vertical asymptotes, x-intercepts. We talked about that with polynomials a little bit. We'll discuss a little bit what happens with them. So here's our function, 2x plus 1, x squared minus x minus 6 on the bottom. What's the x-intercept? So how do you find x-intercept? Set y equals 0, solve for x. So f of x, that's our y. So we want to take this thing and solve that for x equals 0. When is that going to be equal to 0? Well, we can just multiply both sides by the denominator. This becomes that. So the x-intercepts are when you take the top of the fraction of the rational function, set that equal to 0 and solve it. So our only x-intercept is solve this for x, which is x equals minus 1/2. Remember that it's an odd multiplicity because the factor we're dealing with, right, that's to the first power. So what's all the information we have about y equals 2x plus 1 over x squared minus x minus 6? We know x-intercept, multiplicity is 1. It's odd. X-intercept is x equals minus 1/2. The behavior, odd, that means we go through the x-axis. Vertical asymptote from before, we talked about vertical asymptotes at some point. Right? We talked a little bit in the previous lecture about finding the vertical asymptotes of this. If you factor the bottom, though, we'll just do this up here. X squared minus x minus 6 is x minus 3 times x plus 2. So we have a vertical asymptote at x equals 3 and a vertical asymptote at x equals minus 2. Multiplicity is 1. Those are both odd. And what does that mean? That means we have the opposite sign on either side, right? Because it's an odd multiplicity. And then the last thing is the end behavior. Doesn't matter what the multiplicity is or whether it's even or odd, but y equals 0 is the end behavior. That's our asymptote as we go out to the left and right. So sketch a graph of this. End behavior. Y equals 0. Let me bring that up a little bit. There's my end behavior. It's like the x-asymptote. We have to figure out what goes on in the middle. We know that minus 1/2 is an x-intercept, and we go through. X equals 3. Vertical asymptote. And x equals minus 2. The other vertical asymptote. And these are both odd multiplicities, so we have opposite signs. To get our graph started, just calculate the y-intercept, and that's set x equal to 0, and that gives me 1 over minus 6. So there's my y-intercept. Great. So how do we sketch graphs of rational functions? This is the skeleton has been put up here. And there's some rules about how to play the game of graphing rational functions. You cannot go through these lines, right? They're vertical asymptotes. You can't go through them. You can only go up to plus or minus infinity. You cannot cross the x-axis except at an x-intercept, where you can either cross it or go through or touch it. depending on whether multiplicity is even or not. So no crossing of these lines, no crossing of this line except here, and you have to end up at your end behavior. So we're starting here. If we want to go to the right, what can we do? Well, our graph starts here and it goes off to the right a little bit. It can't cross this part of the x-axis because there's no x-intercept there for it to leak through. And as it gets closer and closer to this vertical asymptote, it can't go through there. It can only go to plus or minus infinity. It can't go to plus infinity because it'd have to cross that x-axis. So it has to go down to minus infinity. This is an odd multiplicity vertical asymptote. So that means opposite sign. If you have negative infinity on this side, it must be plus infinity on the other side. Can't come down and touch this. So you just come and hook up with your end behavior. What about going to the left? Well, you go to the left, you have to go through this point, and that has odd multiplicity, so you have to go through the x-axis. And now you're up in this box. Going to the left, you can't cross this line, and you can't cross this part of the x-axis because you don't have an x-intercept to go through there. So you're going to have to go up to plus infinity. Odd multiplicity, which means if you went up to plus infinity on one side, you have to go down to minus infinity on the other side and hook up with your end behavior. And there's a graph of our rational function. So what about this one? What's all the information we have about this function? Use it to sketch the graph. So end behavior. How do we find end behavior? You take the ratio of the leading term in the top, and that's just an x. Oh, which one is? Hang on one second while that's not what I want. That is supposed to be a 2 there. X minus 1 squared. So y equals 3 is our end behavior. X-intercepts, x equals 2. Touch because it's a even power. X equals minus 1 from this factor, and you go through because it's an odd power. Vertical asymptotes, one is x equals 1. Even power, so same sign. And the other one is x equals minus 5. Opposite sign because power is 1. Okay, so what does our graph look like? We have to start at y equals 3 and end at y equals 3. So there's my end behavior. We know that at 2, we go through. And at minus 1, no, at 2 we touch, and at minus 1 we go through. And we got a vertical asymptote at x equals 1. And so x equals 1 is my vertical asymptote. And the other vertical asymptote is x equals minus 5. So since our end behavior is not on the x-axis, we don't need to know where the y-intercept is. We know we're starting here and we want to go from left to right. Starting here in this box, how does the game work? We can't cross the x-intercept. And when we hit the vertical asymptote, you have to go to plus or minus infinity. So since you can't cross the x-intercept, you have to go up to plus infinity. X equals minus 5, odd power, so opposite sign. So plus infinity on one side means that you're going down to minus infinity on the other side. So as we keep going to the right here, we get to this minus 1. That's an x-intercept. You go through the graph, through the x-axis. We end up here somewhere. Now we're going to the right. We can't cross this bit of the x-axis because there's no x-intercept there. As we approach this vertical asymptote, x equals 1. Since we can't go down to minus infinity, we must be going up to plus infinity. X equals 1 is a even power. It's x minus 1 quantity squared. So we have the same sign on both sides. We went to plus infinity on one side. Got to go to minus infinity on the other side. X equals 2 is an x-intercept where we touch the graph. So we come down, touch the graph, and end up at our end behavior. And so there's the graph of our function. So it's not too bad graphing rational functions. It's sort of following through this game. So here's the one where I wanted to have the power there. So end behavior. Y equals -2, and I've got an x cubed on the top, x squared on the bottom. Remember that this power is just the sum, is the count of all the factors. 2 factors plus a third factor, that's 3, 2 factors at the bottom. So y equals -2x. X-intercepts, we've got one at x equals 5. And we touch at that point because it's an even power. The one at x equals 3, we go through because it's an odd power. Vertical asymptotes, we've got one at x equals -1. Opposite sign because it's an odd power, it's now 1. And at x equals 1, opposite sign because we're going through. So I'm going to zoom out a little bit here so we can try and keep track of what we're doing. Okay, so what is our graph going to look like? Start with the end behavior. We're going to start up there and end up down there because that's what -2x looks like. Odd power with a minus coefficient, so we look like that. X equals -1 is a vertical asymptote. Right, and then, so that's x equals -1, that's my vertical asymptote. X equals 1 is another vertical asymptote. X equals 3, I'm going to move this out to the right a little bit so that I have some space. X equals 3 is one x-intercept, and x equals 5 is another. Okay, so what happens? We'll start here, and we work our way this way. We hit a vertical asymptote, can't cross the x-axis, so we have to go up to +infinity. X equals -1, opposite sign. So that means if this side went to +infinity, that has to go to -infinity. As we come out of here, we can't cross this bit of the x-intercept. And so we're going to have to go down that way, right? Because we can't go up to +infinity, but we can't cross the x-axis because there's no x-intercept there. So we have to go down to -infinity. X equals 1, vertical asymptote with opposite sign. So if this goes down to -infinity, this side has to go to +infinity. At x equals 3, that's an x-intercept where we go through the x-axis. At x equals 5, we touch the x-axis, and then we hook up with our end behavior. And there's our graph. And this is a vertical asymptote. Let me make that a little bit darker. So there's our graph. Just work it from left to right. And then finally, what about this one? End behavior. We'll zoom in so we can actually see this writing, and then we'll zoom out to do the graph. Try to autofocus that so it's actually legible. Great. So what's our end behavior? Y equals x squared over x to the 5th, 1 over x cubed. So that means my end behavior is going to be the x-axis. X-intercepts, x equals -4. Go through because it's an odd power. X equals 1. We go through because x -1, that's where the x equals 1 comes from. That's also an odd power, so you go through. Vertical asymptotes, x equals -3, so that comes from here, because if we said x equals -3, that makes that 0. Even power, so same sign on either side. X equals 7, odd power, so opposite sign. So if we put all this together, and we'll zoom out a little bit so that we can actually see everything together. All my information and my graph. Focus. Okay, so what we got going from left to right, we've got an x-intercept at -4, right, where we'll go through. We've got a vertical asymptote at -3. We've got an x-intercept at 1, where we'll go through, and we'll have a vertical asymptote at x equals 7. And then our end behavior is the x-axis. So end behavior is this. Now, when your end behavior is the x-axis, you don't know whether, when you leave here, whether you're going to go down this way or go up that way. So we really want to find the y-intercept so we can know how to start. So what I don't particularly care about the y-intercept is what the actual number is. I just want to know whether it's positive or negative. So my y-intercept would be, if you plug in x equals 0, it would be 0 plus 4, 0 minus 1 over 0 plus 3 squared times 0 minus 7 cubed. So that's what my y-intercept would be if you just plug in x equals 0 into everything. And that would be negative, oh, that's actually positive, my bad. Because this is positive, this is positive, this is negative, and this is negative, and there's 3 negatives. So actually I have 4 negatives, 1 here and 3 there. 4 negatives make it positive. So my y-intercept is up here somewhere. And now we can get started, right? Rules of the game, you can only go through the x-axis at an x-intercept. You can't go through a vertical asymptote. When you hit a vertical asymptote, you have to go to plus or minus infinity. So we're starting here. First thing is we go to the right, we hit this x equals 1. That's a x-intercept, and we go through there. And now there's no x-intercept here, and we hit a vertical asymptote, so we have to go down to minus infinity. X equals 7, odd power, so opposite sign, minus infinity on one side, plus infinity on the other side, and you go down like that. Working from the left, right, no x-intercept here, so that means when I get to this vertical asymptote, I'm going to have to go up to infinity. Minus 3, it's got the same sign, so if I went up to plus infinity on the other side, on one side, I have to go to plus infinity on the other side. Minus 4, you go through, and then hook up with your end behavior. And so there's the graph. So graphing it isn't really hard. You don't actually have to do all that stuff with the figuring out the vertical asymptotes, because the behavior in the vertical asymptotes just sort of drops out of everything else. So a little thing about how to go about graphing these things. I think my math lab calls it the 7-step procedure, except I don't pay any attention to the finding the symmetries. So how do you graph a rational function? Find the end behavior, sketch it in. There we go. Find the end behavior, sketch it in. Find the vertical asymptotes. It's looking at the denominator. Where's the denominator 0? Sketch in the vertical lines for the vertical asymptotes. Figure out if they have odd multiplicity or even multiplicity. Find the x-intercepts. That's where the top is equal to 0. Put them on the graph and determine if they have odd multiplicity, which means you go through, or even multiplicity, which means you touch. If the x-axis is the horizontal asymptote, you have to find the y-intercept. And so you connect up that skeleton of your graph with these 3 rules. You have to start and end with the end behavior. You can't cross the vertical asymptotes. You have to go to plus or minus infinity when you get to a vertical asymptote. And you can only cross or touch the x-axis at an x-intercept.